Today we are going over polynomial functions with writing them in standard form, naming them, and combining them. Okay. So standard form, for standard form for a polynomial, we need to start with the term with the highest exponent, then go in descending order. So you write your terms in order from the highest exponent going to the lowest. Now, if your polynomial has a negative exponent or a variable for an exponent, then it is not a polynomial function. Okay? So it is not a polynomial function. For instance, that would be like x to the negative first. Or like 3 to the x. Okay, our exponents are negative or they're variables, so those are not polynomial functions. The degree, for names and types of polynomials, the degree of the polynomial is your highest exponent. That highest exponent will tell us what the degree is, like the name, okay? It'll also tell us another important thing, like our leading coefficient. So we have to make sure they're in standard form, highest exponent to the lowest. So if your degree is a 0, your highest exponent is 0, this is called a constant. Okay? It's a constant. Example of that would be like y equals 4. Is there a variable there? No. So if it doesn't have a variable, then it's a constant. And another way we can write that is f of x equals 4. Remember, y and f of x mean the same thing. F of x stands for the function of x. If your highest exponent is a 1, this is called linear. Example of that would be like y equals x plus 2. Or f of x equals 3x minus 9. Your exponent for your variable is a 1. That's our degree, and that's the type, linear. If your highest exponent is a 2, this is called a quadratic. So example of those could be y equals x squared plus 3x minus 5, or f of x equals 2x squared. Your highest exponent is a 2. If your highest exponent is a 3, these are called cubic. So we could have y equals x to the third. Or f of x equals negative 4 x to the third plus 3x squared minus x plus 1. Those are all examples of cubic functions because your highest exponent is a 3. Now 4, if your highest exponent is a 4, we call these quartic. The way I remember these is because it takes 4 quarts to make a gallon. So an example could be y equals 3x to the fourth minus 7, or f of x equals negative 2x to the fourth plus 3x to the third minus 7x squared plus 4x minus 1. Okay? Those are all examples of quartic functions. The leading coefficient is always your first number in the polynomial in standard form, so it leads everything. Alright, so remember, you can stop, pause this at any time, so to keep in line. Okay, let's decide for this next slide. Let's decide if these are polynomial functions, and if so, we'll write them in standard form, state its degree, the type, and leading coefficient. First, is this polynomial function? F of x equals 13 minus 2x. Remember, we can't have a negative number for an exponent or a variable. So look at our exponent. It's a 1. So yes, this is a polynomial function. Now, is this in standard form? It is not. We need to switch it around. So it'd be negative 2x plus 13. We're writing this in order. Now your degree is your highest exponent, which is 1. So it'd be a first degree. Our highest exponent was a 1, so the type of those are called linear. And then our leading coefficient is the thing that leads everything, negative 2. Let's look at this next one. F of x equals x squared plus 4x to the fourth plus 3 minus 5x. Well, do you see any negatives or variables that are exponents? No. So yes, this is a function. So I just need to write it in standard form. We start with our highest exponent first, so 4x to the fourth plus x squared minus 5x plus 3. Our degree is the highest exponent, so it's the fourth degree. Our type was quartic because it takes 4 quarts in a gallon. And our leading coefficient is 4. Okay, let's look at this next one. Decide if this is a polynomial function. So if we're looking through here, look at your exponents. 2, negative 1, 1. Uh-oh, we got a negative exponent. We are not allowed to have those, so no, it is not a polynomial function. And from there, we don't have to answer anything else. So now look at the next one. Look at your exponents. 5, 1, x. That's another uh-oh, okay? We do not like exponents to be variables, okay, for polynomial functions, so no. The next part of this section is called direct substitution. Direct substitution means just plug that number in for the variable. So for this one, we are using when x equals 3, so I'm going to plug 3 in for x, and then I will solve. Okay, so you could multiply these out, or you could use the nice handy dandy calculator. And when I do that, I get 23. So again, you know, for this next one, we're going to evaluate this when x equals 4. So if you notice, what am I putting around that number that I'm evaluating? Putting parentheses around it. And especially if you're going to use the calculator, it's going to be very important that you do that, okay? Especially if you're using a negative number. Okay, so you can see the numbers I'm getting. So here in this last one, I'm plugging negative 2. So this is going to be very important if I put, you know, to put negatives around the number that I'm plugging in. Okay. So those should be pretty easy, just direct substitution. Now synthetic substitution, you can, you know, look at the steps here, okay, of what we need to do. So if you want to pause it, you can look at the steps. I am going to go ahead and go to the next problem and show you how to use synthetic substitution. Synthetic substitution is just another way that we can use to solve these other than direct substitution. So first thing I'm going to do is I'm going to look at my exponents. Do I have all of them? 4, 3, 1. You are missing the 2. So in that case, we need to put a 0 where that would normally be. Okay, so I'm just writing my numbers, my coefficients, and I'm going to evaluate this when x equals 3. So I put this long L here because I'm going to have some numbers go in between here, and then I'm going to combine them, and they're going to go underneath. So all I've done is wrote my numbers, my coefficients, and since I didn't have x squared, I put a 0 in its place. So the first thing I'm going to do is I'm going to bring the 2 down. Now all these numbers underneath the L, I'm going to take and multiply by the number outside. So 2 times 3 is 6. That goes underneath my next term. Combine those. 6 minus 5 is 1. 1 times 3 is 3. Combine those. 3 times 3 is 9. Combine those. You get 5. 5 times 3 is 15. Combine those, you get 23. Now this last number is our solution. Okay, if we plug 3 in here, we'd get 23. And if we look at this problem, this first problem, compare it to our first problem that we used direct substitution, this right here, we got the exact same answer, 23. Okay, so let's try another problem. Remember, you can always pause this at any time. So if I'm looking at my exponents for this one, 3, 2, 1, 0, I have all of them, so I don't need to put a 0 in any place. Now synthetic substitution is going to help us when we divide polynomials and have to divide using synthetic division. Okay, it's going to be very similar. I'm evaluating this when x equals 2. So I bring my first number down, 5. Multiply it times the number outside, you get 2. 5 times 2 is 10. Combine these. 13 times 2 is 26. Subtract. 26 minus 1 is 25. 25 times 2 is 50. Combine those, you get 57. And then the last one, do you have all of your terms? Four, 3, 1, you're missing the 2. So you have to put a 0 where that would be. This is our fourth term, third term, quadratic term, our linear term, and our constant term. Now I'm evaluating when this x equals -1. So bring the -2 down, multiply it by -1. Get +2. Combine those, you get 1. 1 times -1 is -1. Combine those, multiply times 1, you get 1. 4 plus 1 is 5. 5 times -1 is -5. Combine those, you get -10. There's your final solution. The next part deals with graphing polynomials. To graph a polynomial, we need to make a table of values and plot corresponding points, and you connect them with a smooth curve. So, we could plug these numbers in and then plot them. Okay, you guys can do that. It's not too bad. So it's just normal plugging these numbers in and then plotting them. So you'd plug -3 into this polynomial. The number you get is your y. Then you'd plot that corresponding ordered pair. Okay. So you guys can do that. I hope you guys have a great night. I will see you guys tomorrow.